Hello guys, welcome back to my channel. Mason African Motives, still working on mathematics N2. So in this platform we shall be having a continuation again on the question paper that we were working on, that is the March 2018 paper. So in this case we have the question on 4.1, that is 4.1, 4.2 and 4.3, and everything is a total of 13 marks there. So as you can see guys, that's what you're having. So we shall quickly rush through the question paper. An ice cream cone is a base diameter of 50 millimeters and a slant height of 135 millimeters. Calculate the following: the surface area, the volume of the cone. Okay, so this is a cone guys. We shall just maybe perhaps you have just a sketch of a cone. So you know that a cone actually looks like this, just a sketch here. All right, let's just put this way, but it's supposed to be upside down. Okay, anyways, as we are just taking a cone guys, we just want to see the concept of a cone, but we're supposed to take it like upside down. So that's our cone guys that we are having, but this is an ice cream cone, so you're supposed to have something like this, maybe this way, so that it can make sense. But anyways, that's what we have. So the diameter is 50 millimeters here, which is this diameter here, and remember that radius is diameter over 2, which is 50 over 2. That's going to give us 25 millimeters. So this will be 25 millimeters. All right, let's just put it this way. This will be 25 millimeters here, and this will be 25 millimeters here. All right, so that's our radius. That's what we have. So let's just say O, A, B, C. Let's just name our points. But this is not important at all. Anyways, then we are given also the slant height of 135 millimeters. This is your slant height. This one, this is your 135 millimeters here. So this is the slant height, which is L. This is the radius, and this is the perpendicular height. So these two are the same. This is also 135 millimeters, and remember this gives us also a right angled triangle if we are to complete this triangle like that. All right, so the first question is for us to calculate the surface area of a cone, of the given cone, and we know that from our formula sheet, it's only that I'm not having the formula sheet now, but we actually know that from a cone the surface area is pi r L. Let me just write it here. This is 4.11. So let's just write as the surface area, which is equal to pi r L plus 2, that's gonna be pi r because this is area, pi r L plus this one. So the pi r L is for this, and we are left with this circle here. So the circle is pi r squared. Okay, but this formula is there in your formula sheet. Don't worry about this. Okay, so you can just put everything here. That's pi times r, which is this radius, which is 25, times, that's our radius there, L, which is the slant height, which is 135. Okay, then plus pi times r squared, which is this one, the radius squared. That's going to be 25 squared, or 25 times 25. So if you were to simplify properly guys, adding these two together, this will give us 4,000 pi. All right, then we can just write this as a decimal. Yeah, choosing to write as a decimal, or you can just write this as this is area in square millimeters, or you can just express as a decimal. That will give us 12566.371. Yes, if we round off, this will be 2371, like that. So that is actually the surface area. So it's always about the concept there that you'll be given. So like I said guys, this was supposed to be upside down, but it's one and the same thing though. And the volume of the cone Okay, we know that the volume of the cone is a third base area times the height, which is a third base area. So this is item 4.12. So volume is a third the base area, which is the base area is pi r squared h, like this. So do we have this height? We do not have. We do not have this height. So let's calculate here our height. We can apply the Pythagoras theorem, since we know that c squared is equal to a squared plus b squared. So we can have the square root. Oh, we are not finding this c, but we are given the c. So let's just substitute before that. So the c, which is the l, which is this one. So we can just use l squared is equal to h squared plus r squared, or r squared plus h squared. So as we need this h, so it's going to be l squared minus r squared is equal to h squared. Transpose this, it's going to be a negative. So that's h squared is equal to l squared, which is this 135 squared, minus r squared, which is this r, which is 25 squared, like that. So we can actually use our calculator. That's h squared will be equal to, simplify this or combine this, we're going to have 17600, that then square root both sides. That's our h is going to be, if you round off, it's going to be 132,665. And these are in millimeters, so this will be our height, which is in millimeters. Take note, guys. So using this height, remember what we need here is to apply this height here that we have just obtained to calculate what the volume here. So we are now having a third times pi times r squared, which is the radius here of 25 millimeters squared, times the height that we just calculated now, which is this value of 132,665. So as we can see, we have to apply the calculator there. This is gonna give us this decimal 8,689,039. So that's what you're going to have, and this will be in cubic millimeters. This is volume, and volume will be in cubic millimeters. So that is the concept there that you're going to have. So actually these typical questions, that's the application. So just confirm they're also using your calculator if we are obtaining the same thing or the same answers here. Then this is actually an application of our previous class that we did on mensuration, where we talked about using the mid-ordinate rule. So that is the concept that you are given to calculate the area. The ordinates in centimeters of an irregular plate are as follows. So these are the ordinates, and we are given the area this time. Calculate the common interval in centimeters. Remember, actually I talked about this and the formula that you're going to apply whenever you are working with the area of an irregular shape, which is I don't know if it is going to be clear here, but this is 4.2. Remember, the formula is for the area, which states that you add, you're also given this formula, guys, the first ordinate plus the last ordinate. So this is going to be the last ordinate, like this, over 2, then plus sum of all other ordinates, or the remaining ordinates. Okay, sum of all other ordinates, which is actually the remaining ordinates in this case, like this, times up the distance that is going to be in between the intervals. Okay, that is let's just say, right, distance, guys, so that we don't waste much time. Let's just say distance there. So we are given this part this time, and this we can determine it because we have got the ordinates, but we are not given this. So we are going to just put this as a D. All right. So not to confuse you, let's just insert our values. Since the area is there, let's just write our area. This is our area, 18,000. That's 18,960 is equal to the first plus the last ordinate, which is the first ordinate is 120 and the last ordinate that is 118. So you add the two there. That's 120 plus 118 over 2, which is part of your formula. So this is part of this one, is part of your formula, these two, plus the sum of all other, which is all that is remaining. What is remaining here? All right, we have taken this 120 and this 118, so we are going to remain with all these ordinates. You add them together. All right, so let's add them together. That's 127 plus, you add everything here, guys. Make sure that you add everything. Okay, that's gonna be 139 plus 143 plus 147 plus 163. Let's just write it here, plus 157. Is because of my space, but you can write these all going. Okay, 148 plus 153 plus 148 again. Take note, do not leave any value. You have to write everything. I don't know if I wrote everything there, but you have to take all these together. Okay, take everything, add them. You remember, this one you're not going to take it because you have taken it on the first and last. So these are the ordinates. You add them times the distance, which we are not given. All right, so I want you to add this and also combine with this. So this one, you can first maybe start by simplifying this. All right, then you add everything. So this is gonna give us 18960, which is equal to, if we add everything here, we are going to obtain 1669 times D, which is just like 1669D. So to find D, you divide by 1669. We find divide by 1669 like this. This is gonna cancel. So therefore, our D is going to be, if we divide these two, this is gonna change to 11,16, and this can change to a 0 there. And these dimensions, everything that you're talking about is in centimeters. So this is going to be also in centimeters. So that is the distance between the ordinates, the distance between the ordinates, which is the interval. Yeah, that will be like the interval. That is the interval actually, which is the distance between the ordinates. So that's how they ask these questions, guys. And the last part is to calculate the volume of a sphere with a surface area of 125 square meters. This is a sphere. We are given the surface area. Okay, remember, on a sphere you can just take an example of a tennis ball or an orange or something like that. It's not like actually a circle, but something like that. But the surface area of that sphere is given by the formula 4 pi r squared, and the volume of a sphere is 4/3 pi r cubed, like this. So we must play around the surface area in order to get the volume. So how can we play around these two? Take note, the surface area we are given, this is 125 square meters. This is in square meters, like that. So definitely I have to equate these two because they are equal. This is the surface area and this is also the surface area. So definitely 4 pi r squared is equal to 125. So I can find the radius here so that I can use it to calculate the volume. So let's divide by 4 pi here. is going to cancel. R squared is equal to 125 over 4 pi. So to find R, I can actually introduce the square root both sides, or I can first find the decimal, then introduce the square root. But you can just introduce the square root. At that stage, you can have your radius, which is rounded to 3 decimal places, going to give us 3,154. And these were in meters, cubic square meters, so this will be in meters. The radius is there, so the volume can be determined because we said it's 4 over 3 times pi times r cubed, which is this radius, 3,154 cubed, like this. So that is it, guys. That's what we are having. That is it there. So applying the calculator, working on the calculator and simplifying this, we're gonna obtain something like 131,424, and these were meters, so this is going to be cubic meters. Remember, volume is measured in cubic units. So if it is meters, it is going to be cubic meters. If it is centimeters, cubic centimeters. If it is millimeters, cubic millimeters. But that is the concept of the volume. So that was the idea there on this typical question that we had. So we shall meet again, guys, in our next class, working on question number 5 and finishing up the question paper that we had been working on, so that we can work on another question paper before we write our exam. So that's it, guys, from Memo African Motives. Till we meet again.